right, this is problem number 69 in section 4.5. A little bit different integral, so we're going to try substitution here. There's no obvious, if you differentiated this, you'd get something close to what's inside there. But you've also got that square root around it, so you probably don't want to try that. You can, and it might work, but I think we're going to try the other way around. We're going to try letting this be u, and see if we can figure out a way to get, to have it work if we kind of back it around that way. So let's let that be u. U is going to be 1 minus x, and that means that x would equal 1 minus u, right? We just switched the x and the u. So u is 1 minus x, and x must be 1 minus u. We also need to figure out what dx is. So dx here would just be negative du, right? So we need something there. We can also take this and figure out what x squared is. X squared would be 1 minus 2u plus u squared. And I think when we do that, we get everything done that we need to substitute in there. So all we're doing here is just a trial and error. You're going to turn this thing around and see if, I don't know how to integrate it the way it is now, but if I do some manipulations, maybe it'll turn out a little bit easier to integrate. And you can kind of assume if it's in this section that that's probably going to be a good strategy. So otherwise, it really is trial and error. So what we have here now, I think, is this. Where the x squared is, I've got 1 minus 2u plus u squared. Where the square root of 1 minus x is, I have square root of u. Let's just call it u to the 1/2 power. And where I have dx, I now have negative du. So I'm going to put the negative in front and just put a du there. Okay? So let me think about this. So u is 1 minus x, so this is just the square root of u. U to the 1/2 du, and then I've got this, thing, a polynomial here, quadratic. So now what I'm going to do is I'm going to distribute this. So this is what Nathan was saying in class. It's a good idea. So this is going to be the square root of u. Let's call it u to the 1/2. I think is easier probably. Minus 2, and this is u to the 2/2 times u to the 1/2. Multiplying common bases, you add the exponents. So 2/2 and 1/2 will be u to the 3/2 power. So u times u to the 1/2 times u to the 2/2 is u to the 3/2. And then over here it's going to be plus u to the 5/2. That whole thing is times du, and it's the negative negative integral of that. All right, so that's a little trick. If you get a square root, you don't know what to do with it. Substitute for what's inside. And sometimes it works out, where you can distribute and then integrate a little bit easier. So we're going to integrate this term by term. So it's going to be u to the 3/2, 2/3 of that. And it's going to be negative, so this negative is going to go with all these. This is going to be minus 2 u to the 5/2, 2/5 of that. And the negative here is going to make that positive. And then it's going to be u to the 7/2 times 2/7, and again the negative is going to make that positive. So the whole thing turns out like that, plus c. Now what you need to do is you need to go back and put that 1 minus x back in for u. So this becomes negative 2/3, 1 minus x to the 3/2 power, plus 4/5, 1 minus x to the 5/2 power, plus 2/7, 1 minus x to the 7/2 power, and then plus c at the very end. So differentiating this and getting that back again looks like a lot of work, but you could do it and you could check that.